Good day everyone, we are welcome to today's session. In today's tutorial, we're going to learn about normal distribution. So normal distribution have a curve which have been shaped as a bell, like it have a bell shape, right? And then the intersection of this bell shape is the mean. It's sometimes called the median or the mode. So it depends on the kind of question that you meet. When they are referring to the median, you have to know they are talking about what they mean, and then if you meet the mode 2, it's the same thing, right? And this is a standard deviation. That's the spread of the curve, how far it could go, right? Yeah. And then because this is a probability, we're saying that probability sum up to 1. Therefore when we divide it into an equal part, here is 0.5, here is also 0.5. And we're saying that this diagram or this curve has symmetrical, which means any probability here or any figure here have an opposite direction here. So if here is -2, then here is supposed to be 2. So that's what we call symmetrical, right? They have a mirror, they are mirror. So whatever is here, it could be found here too as well. Yeah. And then the intersection or the interval here we say it's negative infinity, and here is positive infinity, which means it goes like that. Okay. So you are saying changing u, shift the distribution to left or right. So by changing the mean, you are shifting the distribution to left, or you can shift it to right. And then changing the standard deviation increases or decreases the spread. So by means of changing this standard deviation, can increase or decrease the spread. All right. So we say finding a normal distribution. I say probability is measured by area under the curve. So if you want to measure the probability of this curve, we're saying that it's measured by the area under the curve. So for instance, if you want to measure the probability from this portion to this portion, that is when you're going to get this shaded portion, right? So we are saying that a is less than or equal to x, while x is also less than or equal to b. So to find the probability of this portion, or to find this interval, we can say that the probability that x is less than or equal to b minus the probability that x is less than or equal to a, right? So you take the probability of this and you subtract this from it. That's when you're going to get this shaded area. What we are saying is that a is less than or equal to this probability. That's the probability of a, which falls beyond the negativity, right? And then the probability of b, which also falls beyond the negative, because we said s is less than, right? Okay, so if you find the difference between the b and then the a, then it means you are taking this part out. We are subtracting the b from the a, so we are taking all these parts out, and then we will be left with only this period here to here. Okay, so that represents the probability. So that's how I can explain it. That, yeah. So whenever you see, you have to find the interval between certain values. So that's how you're going to do it. You're just subtracting the probability, this probability, from this probability, right? So something like b minus a, and then you get the interval that we are talking about here. All right. So as you go forward, you will get it. You understand. So that's how they get the probability here. They said the total area under the curve is 1. We've talked about it. And the curve is symmetric. So half is above the mean and half is below the mean. Yeah. And then we said this place is negative 0.5. So therefore here 2 is, sorry, this place is 0.5. So here 2 is 0.5 because it's symmetrical. They are mirror to each other, right? Okay. So the standard normal distribution. So the standard normal distribution is also known as the Z distribution. It has a mean of 0 and a standard deviation of 1, which possesses the same probability distribution as the normal distribution. So when a normal distribution, right, have a mean of 0 and a standard deviation of 1, we call this as a standard normal distribution, right? So we are saying that when a distribution is having a mean of 0 and a standard deviation of 1, then it poses the same probabilities as the normal. That's the normal distribution, right? So they say the value above the mean have positive z values and the value below the mean have negative z values. So this is the mean. So the values above the mean, so above the mean have positive and below the mean have negative, right? And they're saying that the standard normal distribution is also known as the z distribution. So this standard normal distribution is a z distribution, right? So if you are asked to, if you are given a probability that you have to find the standard normal distribution, you have to know they are talking about the z distribution. Therefore, we are going to use the z table to find your probabilities. Is there any normal distribution with any two mean and standard deviation as a combination can be transformed into a standard normal distribution, that is z, through this formula? So we are saying that whenever you are given a probability or you are given a sample, that they give you the mean and then the standard deviation, right? And then you have to find the standard mean. But to find the standard normal distribution, then you can find by using this formula, where we say this z is equal to x minus u all over the standard deviation, where this u is your mean. So that is to translate from any normal x to a standard normal, the z distribution. Subtract the mean of a random variable from the value of x and divide the differences by the standard deviation of the random variable. So what we are saying is that when you are given a mean, to find this, we have to find the probability of a normal distribution, right? And then you are given the mean and the standard deviation. Then yes, you can find the standard normal distribution by using this formula, the s minus of mean over your standard deviation. So they gave example here, and they said if x is distributed normally with a mean of 100 and a standard deviation of 50, the z value for x is equal to 250x. So here you have to find the z value, and we know the z value is the standard normal distribution or the z distribution. And we know to find the z value, we are saying that z is equal to x minus the mean over our standard deviation. And in the question, our x was 250 and our mean was 100 and our standard deviation was 50. So when you put this and you point them on a calculator, when you calculate them or you calculate them, you're going to get 3.0. So this is the value for the z, right? So if you are to find the probability, then it means you need to visit your z distribution table and then trace the value. We work on that, but then let's first check here. They say comparing x and z. So in the question, our mean was what do you call 100. So you write your mean first, right? So you draw a diagram and then you show your mean. Always when you draw the diagram, identify your mean first. So that's the perpendicular bisect, that's your mean, and then you show your x, that's the interval. So your x, so this is the x, that's the 250 here, and then you label 80x here. Okay, so when you transform it, you get your 3.0. So you show a 3.0 here, so that represents the value, the x value, right? Okay, and then our 0 here represent the mean. We said a standard normal distribution had the mean of 0 and a standard deviation of 1, so it's constant. So always your mean is 0. So you show your mean and then you indicate that this is the z. So it's either you're going to draw two diagrams and then you show them, like you draw your first one representing the x and you draw another one representing the z, or you can have both of them on the same diagram or the same curve. Okay, so we solved our z, we had 3.0, so you need to visit the z distribution table and then find the probability for that 3.0. Okay, so this is the z distribution table, but before we find the probabilities, I want to make some clarity here. So you see this table, we have a shaded portion here which shows the cumulative probabilities. This cumulative probabilities is telling us that all the probabilities here in this diagram are found here, right? And then here, that's their limit where this line is, have been labeled Z. So which means all the probabilities here, they are less than Z, right? So all the probabilities there are less than Z. So when you are given a question where they said the probability is less than Z, or Z is less than that probability, then it means any probability that you find here will be your answer. You find within this range is your answer, right? But in case it says that the Z is greater than the probability, which means you are going beyond your limit, and then since the probability sum up to 1, then it means the probability that you are going to find within this range, you subtract it from 1. That is when you get your Z being greater than the probability, right? Yeah. So taking it again, all the probabilities here are within the shaded area. So when you have to find a probability that when you are to find a value which is less than Z, then it means the probability that you find within this range remains the answer. But when the question is given that they said find Z which is greater than the probability, then it means you are going to subtract 1 from the probability that you are going to find here, and that will be your final answer. I wish we understand more better as we solve more questions. Okay. So this represents the negatives. So in case your Z, when you find for the Z value, you had negative attached to your answer, assuming negative 3.0, you are going to find a probability here within this negative range. You see the Z column shows a negative numbers, right? Yeah. So when it comes to this range too, this one shows positive numbers. The accumulated probability shows the positive numbers here, and this percentage or this shaded portion represent the probabilities here. So which means any probability here falls within this shaded portion, and this is the limit, which means all the probability here, they are less than Z, right? So all the probability here are less than Z. So if you want a probability that is greater than Z, a probability that is greater than Z, then we say 1 minus the probability that is found here. That is when you're going to get something beyond the limit. Okay. So in the question that we were solving earlier, our Z was equal to 3.0. So we need to find 3.0 within this portion. And as you can see, this is 3.0 here. So this is 3. And you come to this place, you have the point 0. Therefore, this is our probability. That's 0.9987. So 0.9987. And then, there's a point, which means there's 0 before a point. But just that we ignore these zeros. So we have 0.9987. So if you have to find the probability within this question, then it means our probability will be 0.9987 here, which means all this shaded portion represents that probability. Okay, so let's go forward. Always you have to know that on an interval is given like this one I've explained it. You are saying that when A is less or equal to Z, where Z is also less or equal to B, you can express it as the probability that Z is less or equal to B, that's this side, minus the probability that Z is less than or equal to A. Then you take the probability from this one, and then you get your interval here. So that represents the interval that's from A to B, right? Yeah. For example, the probability that the interval for this question, they said 0 is greater than or equal to Z, 0 is less than or equal to Z, where Z is also less than or equal to 2, right? So this one can be written as the probability that Z is less than or equal to 2 minus the probability that Z is less than or equal to 0. Because this one is in Z value, you just go to your distribution table, you find the value for these two and the value for this 0, and then you subtract, right? So here is the case. You are saying that z is less than or equal to 2. So let's go to the z distribution table. This is the z distribution table, and then they are saying that the z value is 2, right? So this is 2, and this was 2.0, this 0.0, so you get 0.9772, but then they said it's less than, which means it's falls between this range. But in case they were saying it's greater than, then it means we have to take it from 1. But since it's less than here, it's less than, so we maintain the answer. That's why we had 0.9772 as shown here. And then z value, which is less than or equal to 0, when we check it from here, so this is 0, there's 0 here and 0.0, so 0.0 here, which we get this value, which is 0.500. So when it comes to the question here, you see they have 0.500, so you subtract and then you get this probability. So this probability becomes the shaded portion here. That's the shaded portion here, right? So when you are solving, we don't subtract the 0 from the 2 and then we go to the probability distribution table to find the values. No, we find the probabilities and then we subtract the probabilities so that we get the probability that we are looking for. How do we solve such a question? We are saying that these are the process for finding a probability using the z table. So to find a probability, or to find the probability of an interval that falls between this range, we are saying that when S is distributed normally, you draw your normal curve for the problem in terms of x. So what we are saying is that when the question is given like this, the first thing you have to do is to draw your curve, right? Draw your curve, and then translate x value to z values. So if the question is given in x value, that here is not z but then x, you have to translate them into z. And then what do you do next? Use the standard normal table to find the probabilities. So after you are done, you use the standard normal tables and then you find your probabilities, and that will be your final answer, right? Okay, so let's see if you can find more examples here and then solve them. So example 1, they say suppose x is normal with mean 8.0. So they will let you know that this is normal distribution. They'll tell you that it's normal, so you know that, okay, you know what you're doing. So suppose s is normal with mean 8.0 and standard deviation 5.0. Find the probability that, like, I find this interval, right? S is less than x, s less than 8.6. So what do we do first? They said first we should draw our distribution table. We should draw our curve. So this is the first step. So they draw the normal curve for the problem in terms of x. So you have to draw the normal curve for the problem in terms of x. And when you are drawing the normal curve, you first indicate your mean, right? And then we said they have a mean of 8.0. So assuming this is our curve, what you have to indicate first is our mean, which is 8 here. And then you have a standard deviation. And what are you finding? You are finding the values between this 8 and this 8.6. So we indicate this 8, but unfortunately here our mean is already 8, so we maintain it and then we indicate the next x value, which is 8.6, and then we label here x. So our next step says we should translate x values to z values, right? So we are translating from x value to z value. How do you translate from x value to z value? We know our formula for finding the z value is our x minus our mean all over our standard deviation. So here our x are 2, we have 8 and we have 8.6, right? Because we said we can write this probability, which is x, which is 8 less than x, which is also less than 8.6, as the probability that x is less than 8.6 minus the probability that s is less than 8. So therefore you have to find s less than 8.6, find the probability that s is less than 8, and then when we are done, we subtract, right? So we are working on two things. So finding the probability that s is less than 8.6. So that's what they solve for s2 here. That's here's our s value, which is 8.6, minus our mean, which is 8, all of our standard deviation, which was 5 here. So when you solve this, you get 0.12, and this becomes the z value, but not the probability. So the z value is 0.12. So you have to go to the z distribution table and find the probability of this 0.12. And then we solve for the other interval, which is 8, which is here. Where is it? This 8. So when here is 8, and our mean is 8, and then our standard deviation is 5, we have 0. This 0 represents the z value, but not the probability for z, right? So you have to go to the distribution table and find the value for this 0. So when we move to our distribution table, when z is 0, we have 0.500000. And when z is 0.12, that's 0.1 and then 2. So this becomes our probability, which is 0.5478. So that's the probability. And since they are less than, which means they fall between the range, so you maintain them. All right. So yeah, so this was the value for the 0.12, and this was the value for the 0.0, the 0, right? So when you subtract this from this, that's the b minus the a, you get this, and this becomes a probability for the interval. This is the interval that's from the 8 to the 8.6, right? So this becomes the probability, which is 0.0478. And then when you get your z values, you have to represent them on the graph, right? So when the interval was 8, when the x was 8, we had 0. So this is 0. And then when x was 8.6, we had 0.12. So we represent 0.12 here, and then we bring our z here. So now we know that this represents the z values, and this represents the x values. You can have two graphs too. You can draw two curves where one is only the x values and another one is also the z values. And then you show your probability, right? So that's the final answer here. Okay. So you have another example here, which also says that we should find the probability for this interval that z lies between 0 and 2, right? So first of all, what you are saying is that you have to draw your curve. So you draw their curve and know that this value is in z already, not x. So there's no need for you to go and find x. So it's in z already. So what you have to do is that you go to your distribution table and then find the probability that falls between 0 and 2, right? So when you search for so first of all, we know that this p, to find the interval, we say probability that z is less than 2 minus the probability that z is less than 0. So when we take this probability out, we are going to get the interval. Okay, so z is less than 2. We go to the distribution table and then find the value of 2. I think we find it already. So that's 2, and then it's 0.0. So we have 0.9772, and when it's 0 to, you have 0.500. So we move back to our question, where so 0.9772 and then 0.500. So when you subtract this, you're going to get this probability, and this represents your probability here, your intervals. Okay, suppose s is normal with a mean 8.0 and a standard deviation of 5.0. So we should find probability that s is less than 8.6. This one you've already solved it. So here is the case, our S is, so you are finding the probability, therefore you have to first draw a diagram, right? And then we know our mean, which is 8. So when you draw a diagram, so it will be like this. Sorry for my, just a sketch, right? So we know our mean, which is 8, so we indicate our 8 here. And then we are finding the interval for x, which is we are finding the x value, which is less than 8.6. So we draw here, because the mean is 8, 8.6 will be here, right? Yeah, and this is the x, so we present here to be x, and they're saying that we should find x is less than 8.6. So s being less than 8.6, it means we are finding the value that's less than 8.6. So probability here, all the probability here, they are less than 8.6. So this is what we are looking for, right? So first of all, you have to translate them. We are done with drawing our graph. We translate them into from S to Z, and we know translating from S to Z goes with this formula. We said Z is equal to S minus the mean over the standard deviation, and then our S has been given here as 8.6. So 8.6 minus the 80 divided by the standard deviation, we get this, right? And then we trace this from our Z distribution table, because now this is the Z value. So, and since you are saying S is less than, so you get Z is less than, and Z being less than this probability means Z still falls within the probability range. So when we trace our 0.12, we are going to get this, right? So this becomes the probability for this side. That's what they indicated here. So all from this place to this place represents this probability. So you can write your S value when you find for, when you translate from the S to Z, you had 0.12. So you can write 0.1. So you can write 0.12 here. This is your Z, and we said the mean is always 0. So have a 0 here. So that's how you solve this question, this particular question. Okay. Let's just suppose suppose S is normally distributed with mean 8.0 and standard deviation of 5.0. Find the probability that S is greater than 8.6. Okay. So first of all, we said we draw our graph, right? So you have to draw your graph. You draw it nicely, and then indicate your mean, which is 8. And you have to find this place, exactly what we saw, 8.6. Here's your X, right? So here is the case. They said it's greater than, so it means it's greater than this 8.6, which means you will find the probability here. Okay, yeah. So you translate this from S to Z, and then we know Z is equal to our X minus our U. Our S minus our U, all of our standard deviation, right? And we know the values. So we just input them, and then you get the value for the Z. But then I said earlier that when you are to find, so the Z value you get will be like Z is greater than. Here it's not less than, right? So it's greater than the probability that you get, or the value that you get. And then I said earlier that when the thing is greater than, we subtract from 1, which means it's like this beyond, how do you call it, above the probability. That's the Z. It lies above the probability. For instance, looking at this, yeah. If you say the probability, the Z is greater than, it means it's beyond this limit, right? So it's somewhere here. So to get this value, we subtract 1 from the probability that we find within this graph, or we find within these probabilities. We subtract it from 1. Okay. So you can rewrite it as So when you solve for this, you're going to get 0.12 as we solved earlier. So the probability that z is greater than 0.12 is equal to 1 minus the probability that z is less than 0.12, because any probability that we find within the z distribution, we are saying that it's less than the z value, right? It's less than the z value. So if you want something greater than the z value, then you have to subtract from the probability that we found within the distribution. Therefore, our 1 minus our 0.5478, which will give us this. So this becomes our probability for this area. Okay, yeah. And you can find this 0.8478 by tracing for the value for the 0.12 within the z distribution table. Yeah, so we have a question here that we need to tackle, and then the question says, a radical chemical company produce explosive for the US Army. Because of the nature of its products, the company devotes strict attention to safety, which is also scrutinized by the federal government. Historical record shows that the annual number of property damage and the personal injury accidents is normally distributed. So they told you that it's normally distributed, right? And then with a mean of 8.3 accidents and a standard deviation of 1.8 accidents, what is the probability that the company will have fewer than 5 accidents next year? More than 10, so more than 10 accidents. So this particular question, the A have been grouped into two. We have AI, which says we should find the probability that they will have fewer than 5 accidents, that's less than 5 accidents within the year. And the II says that there will be more than 10 accidents within the year. So here is the case. You have your standard deviation. We have your mean, right? Your mean, let me represent by u, which is 8.3, and then your standard deviation, which is also 1.8. You have to find these probabilities, right? So we said that first of all, you have to draw your graph. So for each of them, you have to draw a graph. So finding for the AI, you draw your curve, and then we indicate our mean, which is 8.3 here, right? And they are saying that we should find s is less than 5. That's less than 5 accidents. So this is the mean. So less than 5 is here. Less than the mean. So 5 will be here, right? And they're saying we should find less than 5, which means you are finding these probabilities. The probability here. So we name here our x. And we know that after we draw our curve, what you have to do is to find the z value. So you know z is equal to our x minus our mean, all of our standard deviation. So you just input in the values. Our x is 5 minus our mean, which is 8.3, over our standard deviation, which is 1.8. So the answer, you point this on the calculator, you get your answer here. That answer is the z value. Go to your distribution table and then find the probability, and that will be the answer for here. That's the first one. The second one too, they said s is greater than 10. So the same thing, you draw your curve, and then you show the mean is 8. So let me clean this part and continue from there. Now let me draw another curve. So this is your curve. Sorry, not drawn to scale. Your mean is 8.3, and now the value they say should be greater than 10. So your 10 will be here, right? This is your x. So here too, when you get the z value, you have to represent the z value here. So assuming the z value, you have 0.12. You can write 0.12 here. The mean, this is the mean, so the mean will be 0. And then the value, since it's less than the mean, it will be negative probably. So you get negative, let me say 0.12, something like this, and you'll be a z. right? Yeah. So for the second one, they said it's greater than x, which means you're finding within this range, right? X is greater than 10, so you're finding within this range. Therefore, if you're finding above x, then when you find your z, you know our z is equal to our s minus our u, which is our standard, our mean over our standard deviation. And here our s is 10, our mean was 8.3, our standard deviation was 1.8. So when you punch in the values, you get the z value, right? So let's assume we had 0. Let me say 3. So 0.3, go to the distribution table and find the probability for that 0.3. So assuming the probability is 4.9, sorry, 0.9975, let me say something like this. What you are saying is that because it's greater, right, it's greater than, we are going to subtract 1. So 1 minus the probability that we just find, 0.9975. And this will be the probability for this portion. I hope you get it. That will be the probability for this portion. So the answer will be the probability for this question, right? So you solve it and then you get the answer. The B says the government will fine the company $200,000 if the number of accidents exceeds 12 in a year period. What is the average annual fine? What average annual fine can the company expect? So here is the case. They are saying that the government will fine the company $200,000 if the accident exceeds 12. So which means you have to find a probability that x is greater than 12. The same approach, you draw your graph. Sorry, you draw your graph. I don't know, it seems I'm tired. You draw your graph, you show the mean, which is 8.3, using the same mean and the standard deviation. 8.3. And now your x is 12. So here is 12. And we are saying greater than. So still this same value, right? So you solve, you translate this s into z, and then you find the probability. So after you get your probability, because it's greater than, you subtract from 1. Subtract from 1, and then you get your probability for this portion. For this portion. So the probability that you get for this portion, you're going to multiply it by this $200, right? So $200,000 times the probability that you have for this portion. So let's assume you had 0.3421. So when you multiply this, the answer that you're going to get, that will be the expected amount or the average annual fine that the company should expect from the government. Yeah, so that is how we work on normal distribution. Yeah. So let me give some explanation on this distribution table, the Z distribution table. Most of the times they said if you are not able to find this table and then you find the other one, because we say they are symmetrical, which means they are the same. So if you had a positive value but then you want to find the probability on this negative Z value, when you get that value, the probability just subtract it from 1, right? So assuming we had 3.0, but then we want to find it from this negative 3.0. So here is our negative 3.0, which will give us 0.0013, right? But then the answer that we had, the Z value was positive 3, not negative 3. So what we are going to do is that we take 1 minus 0.0013, and the probability that we get should be the same as the probability that we are going to get if you are to find it from the positive Z value. So this gives us 0.9987, right? So let's search it from the positive Z values. So positive Z value for 3.0, we have 0.9987. So in case if you have negative value 2 and you want to Set it from the positive probabilities, like the z-value distribution, positive side, and then convert it to the negative. You just, the probability that you get from here, you subtract it from 1, and then you get for the negative side. So that is all for today's session. Yeah, I wish we understand. Go through it again, draw some notes, and then you'll be fine. Bye.